Alright, we're going to wrap the week up talking about Chapter 6, Section 4. The good news about today is that it doesn't require any new learning. Hopefully you've had some time, even though I've been gone, I'm sorry, but hopefully you've had some time to practice the substitution elimination stuff. But it means that you can also use today as a moment to try to get better at each one. The bad news is that today is based off of application problems, so you're going to have to prepare your mind for thinking, processing, before the work even starts. The best way to get today's information is simply to just do them, so let's just go ahead and get started and see how it goes. I've got about 5 problems to talk through with you today. The first one talks about a person paddling to a camp at a speed of 4 miles per hour while traveling downstream 7 miles per hour if the kayaker is paddling at a constant rate. What's the speed? What this is talking about here is something where you're in a boat. Sorry, that's a terrible boat. And the water is going this way. That whatever your speed is, the water is going to add to it if you're going that way. But if the water is going this way and you're going that way, that the water is going to take away from it. And so what you do is, upstream means that you're going against the waves. Downstream means you're going with the waves. So you have S, the speed of the boat. You have C, the current of the river. And so what you do is you take your speed plus the current is going to give you whatever your two things together is. And speed plus current should be faster, which means that's why you set it equal to 7. Your speed minus the current should be when you're going that way against the waves, which means that that will be your smaller number there. Now the nice thing about this problem is that your C's are already set up to cancel. You can simply go 2S equals, because the C's cancel out, equals 11. Dividing by 2, you get S equal to 5.5 miles per hour. If they want the speed of the current, well, you take and just plug it in here. Speed plus current equals 7. Then 5.5 plus C equals 7, or subtract your 5.5 from both sides. I think that's 1.5 miles per hour whenever you get done with that one. So again, the nice thing about this problem, anytime you're talking about someone with a speed against a speed, just do speed plus current or speed plus whatever they're going with or going against, and then that way you can actually get that set up the right way. Another problem we're going to look at is going to talk about rides at a place that you're getting to and finding out which one's going to be cheaper. You've actually done this kind of problem before, but we're going to do it a different way. What we are going to do here is, it says these are 2 ticket options. Of course, one of them is charging $7 plus 20 cents per ride, so it's cheaper per ride but higher per admission. B is more or less per admission but more per ride. And so what you do is you set up both equations. Y is equal to, again, that's the admission price plus 0.20 R, let's say, per ride. And on this one, your other Y is going to be $3 plus 0.40 R. So again, $7 plus 20 cents per ride, $3 plus 40 cents per ride. Notice this is set up for substitution, to where all we have to do is box and switch these things here. So this is going to end up over here. We end up with 3 plus 0.40 R equaling 7 plus 0.20 R. And from there we just work that out the way we know. So here we will subtract 0.20 R, getting 3 plus 0.20 R equaling to 7. Subtracting 3 from both sides, of course, to get our R by itself, and then dividing by 0.20. R would equal to, let's see, 5 of those would make 1, so 20, I believe. I think so. Let me check on my calculator real fast. Yes, 20. So what this is saying is that 20 rides, because notice you paid more at the admission, which means that up to 20 rides, this really isn't worth paying that much, but at 20 rides is where they're equal, which means that if you're going to ride more than 20 times, this is your best call. If you're going to ride less than 20, the $3 option would be your best call. But again, notice we just used the stuff that we learned a while ago, or this week, to try to get an understanding of what's going on. This talks about a fashion designer making and selling hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. They want the person to break even. The way you work this out is you talk about sales and you talk about expenses. And whenever you separate it that way, In order to break even, you need those two things to be equal. And so when you look at the cells, the material for each hat costs $5.50. That's not a sale. The hats sell for $12.50 each, so I'm going to put 12.50H, $12.50 per hat. But they're spending for the hat, which is $5.50 per hat. They're also spending $1,400 on advertising, but that's a one-time price. And so notice your sales are $12.50 per hat. Your expenses are $5.50 per hat plus $1,400. We just want those two things to be equal, and that's really all you're going to do there. So you take those two things and you solve it by subtracting 550H, drawing a big line. I only have one arm right now. That leaves us 7H equals 1,400. Then dividing by 7, H is now equal to 200. So that person would have to sell 200 hats in order to make the cost of buying advertising worth it. Otherwise they're behind and they're going to lose money. The way that would usually set up though is that you would have your Y equals 1250H and your Y equals 550H, and of course that's why they ended up being set equal. But if you see that problem, feel free to work it out that way, because that is the honest best way to do it. This is the one that pushes people and makes them think a lot. You're attempting to create 10 liters of 40% solution by mixing 30% solution with 70% solution. How much of each must be added together to be successful? What we are looking at here is I have some amount of solution plus another amount of solution that's going to add up to 10 liters. And again, I don't know how much of each one. But what you can say is that 40%, 0.40 times the whatever amount there, because it's 40% solution, plus 30% of whatever is there is going to equal I'm sorry, you wanted 40% solution. You're mixing 30 and 70, so it's 30, 30% solution and 70% solution to make 10 liters of 40%. So you want 40%, and you have to consider the fact that you are making 10 liters of it. So notice it's percent times amount plus percent times amount equals percent times amount. This here is just talking about how much you want altogether. But again, when you're talking about the percentage, it's percent times amount plus percent times amount equals percent times amount, which when you work that out ends up being x plus y equals 10 and 0.30x plus 0.70y equals whatever 40 times 10 is, which is 4. From there, we can substitute, we can do whatever we want there. I think I am going to take the I'll take the elimination route, and just watch carefully as we do this. To make this match that, I'm going to multiply by 0.30. And so what I end up with is 0.30x plus 0.30y equals whatever 0.30 times 10 is, which is 3. Then I take my second equation, 0.30x plus 0.70y equals whatever that second one is, which is 4. Again, keeping in mind, switch all your signs. As you do that, you end up with negative 0.40y equals negative 1. And then of course that means that positive 0.40y equals 1, and you divide by positive 0.40. Let me use my calculator here again, which is 2.5. And then of course, to get your other answer, take that 2.5, plug it in here, subtract your 2.5, ending up with, that would be 7.5 for 30% solution, because remember that's attached to x, and 2.5 of 70% solution. And the last one you need to be ready for, kind of like the same. You're talking about money here. 21 coins, all nickels and dimes. Again, remember, whenever they give me a total of coins, talking nickels and dimes, it means my nickels plus my dimes has to equal 21 total coins. It says the total value is 170. So what you do is amount 5 cents per nickel plus amount 0.10 per dime equals 21. This time I'm going to do it using elimination. So what I'm going to do here is I'm going to take this top equation and I'm going to rewrite it by moving d over there, which of course is going to give me 21 minus d, which allows me then to say this is alone, and that's what I'm going to put in for it. I then substitute 0.05 times 21 minus d plus 0.10d equals 21. We then have to find out what 0.05 times 21 is. So 1.05 minus 0.05d plus 0.10d equals 21. Put these two together. That makes 105 plus 0.05d equals 21. Subtracting the 1.05, and get 1995, and then dividing by 0.05 here gives me 399. Whoa, that's wrong. I put the wrong number. It goes back to here. My total value was 170. Sorry. So that should be 170. This should be 170. This should also be 170. And 170 minus 0.05, or 1.05, is 0.65. And then when you divide that by 0.05, you end up with the answer of 13. Sorry about that. Which means that if I have 13 dimes and I have 21 coins altogether, that I have 8 nickels. But notice how I caught it. The answer I got was way above 21 coins. But again, the reason why it was that I had 5 cents per nickel plus 10 cents per dime should have equaled the total amount that I had in my pocket, which was your 170. You might want to try that again on your own before you move forward. But again, all these should be 170s, 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 again 0.65, and then from there you're good. So go on to your Math Excel, try that stuff out. You do have a quiz on all this tomorrow. It's not going to be too tough because of the fact that I was gone all week, but you do still need to be prepared for some of the stuff that's on there. Majority of it's going to be over the substitution, elimination, and the graphing or solving by graphing. So make sure you're ready. Good luck.